Welcome everybody to video number 3 in a 3-part series where we talk about, again, fresh property tests of concrete. The test today we're going to talk about is the air meter. Oh my gosh, I love the air meter. I have studied the air meter to death. There's other videos on my YouTube channel all about air meters, okay? There'll be more to come as well. There's 2 main types of air meters. There's something called an ASTM C231 Type B air meter. Now there is a Type A, there's something called a rollometer, okay? But the most commonly used air meter, again, is a Type B meter. Then there's a new up-and-comer, a new air meter that shows a lot of promise. And it's described in AASHTO TP118, and it's called the SAM, or the Super Air Meter. And it will give you the same thing a normal air meter gives you, but it gives you a little bit more. It tells you about the spacing of the bubbles inside the concrete, and that can be really helpful. When we make concrete for climates that are wet and then they freeze, and that concrete needs something special. It needs something extra. It needs something called an air entraining admixture. Yeah, and this is a soap or a surfactant that you add to the concrete that helps stabilize bubbles. And these bubbles that are created during mixing are cast into the concrete. So while some air just naturally is trapped while you mix the concrete, the soap stabilizes way more. And the distribution it makes, these bubble sizes, are small and well distributed. This is great. This is what we want. And we'll eventually talk about freeze-thaw durability, and we're going to talk a lot about bubble size and bubble spacing because they're really important. But the most common way to measure this is with something called a Type B air meter. And this meter takes the 1/4 cubic foot unit weight bucket that we talked about before. This is the same bucket that I talked about in video 2. It's already full of concrete. It's already finished. It's perfect. It's ready to go. But then you strap a lid on it, okay? Then you add some water between the lid and the concrete to fill it all the way up. And finally, you pressurize the top chamber to a known pressure. It's about 14.5 psi. And you release this into the bottom chamber by hitting a lever, and you smack it with a mallet. How do you smack it? Smartly. Ha! Let's show this in pictures. You have your bucket. You fill it up 1/4 cubic foot in a very established standard manner, 25 rods, 3 layers, smacking it with a mallet between each one. You put the lid on top. You add water through these petcocks to fill up this area in between. And then you pressurize the top chamber to about 14.5 psi. I'm going to show over here what happens in this graph. You pressurize the top chamber to 14.5 psi. The bottom chamber stays at atmospheric pressure. You hit the lever on top. You smack it with the mallet. And you take it from atmospheric pressure and from 14.5 to something in between. And that something in between, that equilibrium pressure, is different depending on the air volume. If there's a lot of air bubbles inside the concrete, that pressure, that equilibrium pressure, is going to be low. If there's very few air bubbles, that equilibrium pressure is going to be much, much closer to 14.5 psi. And the reason why this works is if you think about all the ingredients inside the concrete that went inside the air pot, none of them are compressible except for the air, right? Rock, sand, cement, water, maybe some other binder. Not compressible, but air, it is. That's why the air meter works. So as I was saying, the equilibrium pressure is used to find the volume of air inside the concrete. And this test is extremely useful to get an estimate of this volume of air. This is great. This is really important because the volume of air is important for the freeze-thaw durability of the concrete. We'll talk about that coming up. But the biggest challenge with this test is that it cannot tell you the size and distribution of the bubbles, at least the typical ASTM C231 pressure meter, where you only run one pressure step. It doesn't tell you the size of the bubbles. It just tells you the volume. And as concretes get more complicated and we start using new admixtures, new material combinations, different construction practices, then we can have an impact on the size and distribution of the bubbles. This means that like 6% air is usually a good volume of air, but not always. Not always. Sometimes if the bubbles are very large, you won't get good performance out of that concrete. You won't get good freeze-thaw performance out of that concrete because we want small, well-distributed bubbles. The only way to really measure the size distribution is to cut the concrete, polish it, and actually use a microscope to measure the size and the spacing of the bubbles. And this is just not practical to do regularly. And this really isn't useful at all while the concrete is still wet, right? You'd have to wait till it's hard. You'd have to polish. You'd have to do all kinds of stuff to it. And we need to know now, is this the right stuff or not? So because of this, a new test was developed called the super air meter, or the SAM. And the SAM doesn't use a single pressure step. It uses multiple pressure steps. And again, I've got other videos on my YouTube channel that talk all about this. But it gives you the volume of air and another number called the SAM number. And the SAM number tells you about the bubble size and distribution inside the concrete. And this is much, much more important for the freeze-thaw durability of our concrete. Again, it's about the size and distribution. Now, the volume is important too, but it's much harder to get the size and distribution that's important. So all this talk about air, how much air do you really need? Well, the typical number is that you need about 6%. And that's a great answer, fabulous answer, especially if your concrete resembles that from 1952, because that is when that number was established. But our concretes today are much different, much more complicated. And with the super air meter, it kind of cuts through this and looks at the size and spacing of the bubbles. And typically a SAM number of 0.20 and an air volume of 4% is what you'd want to look for in the super air meter. And this SAM number is going to correlate to a bubble spacing or a spacing factor of 0.008 inches. Don't worry, we talk about freeze-thaw durability. We'll talk much more about that. So the SAM is still being investigated by a number of organizations. It's being looked at by about 39 different states right now in 6 countries. That's a lot of people. A lot of people are trying this because this is an important issue for them. And the measurement of the air content is one of the only durability checks we do. Can you believe that? Of all of these things we talked about, all of these fresh property tests, slump tests, the unit weight test, this is the only one that really ties to durability. It's an important one. Also, it's very challenging to consistently get the air content right in your concrete. It's known to change a lot. This makes it very tough. But the super air meter is a useful tool, again, to help you figure out if you get the air you want and if it's going to be consistent inside your concrete. Thanks, everybody. That's it for Fresh Property Tests.